In this lesson, we're going to learn how to solve and create proportions to solve problems that deal with scale drawings. It says a scale drawing is a diagram, map, or model of an object that is too large or small to draw. The dimensions are proportional to the actual dimensions of the real life example. So scale drawings are things like maps, blueprints, and floor models. The scale on a scale drawing is the ratio of the drawing lengths or model to its corresponding actual lengths. Study tip. Scales are written so that the drawing distance comes first in the ratio. So it says 1 inch equals 12 feet. That means that 1 inch represents the model and 12 feet represents the actual. So now let's do some examples. Example 1. On a map of Florida, the distance between Coral Springs and Fort Lauderdale is about 4.1 centimeters. The scale of the map is 1 centimeter equals 4.5 kilometers. What is the actual distance? So let's start with our scale and set up our proportion. 1 centimeter equals 4.5 kilometers. We know that when we set up proportions, we want to keep our like units together. So it tells us on the map is 4.1 centimeters. That's my clue. 4.1 centimeters goes up top and x in the denominator. Now we just need to cross multiply and solve our proportion. When I multiply, I get 18.45. And because across from x I just have 1, really no need to divide. I just know that my answer is 18.45 kilometers. Let's try example 2. On a map of North Carolina, the distance between Raleigh and Charlotte is 3 1/4 inches. The scale on the map is 1 inch equals 40 miles. What is the actual distance? So I can approach this problem a few different ways. I have a mixed number. I can either make it an improper fraction or I can make it a decimal. I'm going to go with decimal. 3 1/4, a quarter is 25 cents, so that's just like saying 3.25. So let's start with our scale. 1 inch, 40 miles. It tells us on the map is 3.25 inches, so inches in the numerator, x in the denominator. When I multiply 40 and 3.25, I get 130. So that means the distance is approximately 130 miles. Example 3. It tells us a scale drawing has a scale of 0.25 inches equals 6 feet. Find the length of the drawing if the actual length is 66 feet. So 0.25 inches over 6 feet. This time, they didn't tell us the model length, they told us the actual length. And my clue was also that I have like units feet. So 66 feet and then x. So now I can cross multiply and divide, but I can also look at this a different way. I know that 6 times 11 is 66, so I can also multiply a quarter times 11. And when I do that, I get 2.75 inches. Now let's take a look at our last example. A designer has made a scale drawing of a living room for one of her clients. The scale of the drawing is 2 inches equals 1 1/3 feet. This time, because 1/3 as a decimal is just a repeating decimal, I'm actually going to change that one to an improper fraction instead. So 2 inches over 4/3 feet. It's okay to have a complex fraction. It then tells us that the length of the love seat is 4 feet long. Find the length of the love seat on the drawing. So feet is in the denominator. And then x. 2 times 4 is 8. That leaves me with 8 equals 4/3 feet. 4/3 x. In order to get the denominator by itself, in order to get the variable by itself, I need to divide by 4/3. And so when I divide fractions, 8 over 1 divided by 4/3, let's do keep, change, flip, or multiply by the reciprocal. So my problem becomes 8 over 1 times 3/4. 8 times 3 is 24. 1 times 4 is 4. 24 over 4 can simplify to 6. So my answer because I was looking for x and the numerator is inches, is 6 inches. Alright, in this problem, we learned how to create and solve proportions to solve scale drawings.